one more problem using our correlation and our line of best fit and things like that. And then we're gonna get into some a couple little side notes here as we're going. All right. So on this one, I've given the total number of fat for a menu item and the number of calories. And so the first thing it asked me to do is it asked me to find the mean number of fat and the mean number of calories.
No.
I'm ready to begin, so I need the side conversations to stop. Okay. So I ask you to plug that in as a warm-up. So I'm going to go over here. I do have that plugged in already. And so pull that up real quick. So here's the data. All right. Once you have the data in, how do you go find the mean fat and the mean calories? Control dot. We're going to add a calculator. Okay. Menu number 6 is statistics.
Stat.
Then go to stat calculations. I'm going to 2 variable statistics. All right. So my X list is X. My Y list is Y. All right. And I hit enter there. I'm going to use my up arrow key so I can go to the top. So my mean amount of fat grams in there was 22.5 is what I would say. Okay. My mean amount of calories is
So the X
457.
with the line over it means
That
mean.
is the mean. Yes, X hat is mean, Y hat is mean. So I'd say 22.5 and I'd say 457. All right, that's my 3 significant figures for both of those. Now, it asked me to construct a data plot. I'm not going to do that right now. If I ask you to do a scatter plot, it'll be kind of like one of the ones that we did in our notes where I have the graph paper for you and just put on the graph. Okay. Now, what's important about the mean fat and the mean calories? What's important about that value? The 22.5 and the 457.
That's where they have to intersect that.
My line of best fit has to go to that point. So if I were to ask you to do something like this on a quiz or test, and I ask you to find the mean X and the mean Y, and you draw a line of best fit and you don't draw it through the mean, then that's not correct. Okay? So your line of best fit, your regression line, has to go through that mean. All right? So if you sketch it, it's got to go through there. Okay? Plot the mean point on your scatter plot, use it to draw a line of best fit. Now it says find the equation of line of best fit. Right now, I'm not worried about you doing the point slope form, kind of like we showed. We showed that was really similar to the regression line. So I would go run the regression line on this. Okay?
Test, we run the regression.
In test, you may run the regression. So if I go menu, statistics, I'm going to go stat calculations. I'm going to go run my linear regression. I have X is X, Y is Y. I'm finding the regression Y on X. That's the normal way of doing it. Y is dependent on X. And I would have this. So my slope would be 11.7. My y-intercept would be 194. Tell me about the R value here. Tell me about the Pearson's product moment correlation coefficient.
It is
Strong,
positive.
strong positive. And we could even say linear since we ran the linear regression. It's a strong linear positive R value. Okay, correlation. All right. If I were to ask you to predict, if I gave you the number of fat content and asked you to predict the calories, what values could I use of the fat content? For what values could I ask you to predict?
Anywhere from 5.
Anywhere from 5 to 34. 5 to 34 is my data set. All right. So if I ask you to predict a 24 gram menu item, you could do that because that's in my data set. If I had one that was super fatty, had 40 grams of fat, then we'd say what? Can't do it because why? Extrapolation. Extrapolation is what some people say. Extrapolation is what it is. All right. So it's extra. It's outside the data set. So there are 2 things when it asks you how good is your prediction, or can you trust your prediction. there's two things that we have to state. What are the two things that we have to give? Is it inside my data set? Is it interpolation or extrapolation? If it's extrapolation, I'm gonna reject it, okay? The other thing is what? The R value. How good is my R value? If my R value is good and it's interpolation, then I'm gonna accept that, okay? Even if my R value is good and if it's extrapolation, I'm gonna reject that prediction. Yes?
What, is there a certain number that defines if it's like strong or weak or moderate?
Yeah, like 0.75 was kind of the cutoff for strong is what we said.
Okay.
All right, so if my R value is better than 0.75 or less than negative 0.75, okay? So that's like 75% right, all right, that's a probability or better, that's strong, okay?
So what
And
point
so
is
if
it?
I'm getting into like the 50s,
Mhm.
I probably would not want that, all right? I would say reject. Now you could say I'm rejecting it because that's more of a moderate one, or whatever the case may be. Yep, all right? Everybody good there? So you'll have several questions that will look something like that on quiz and on test. All right, we'll do a couple examples of that tomorrow. I think you have two that you have to do on your quiz tomorrow. Okay? All right. So the next little subject that I need to discuss with you, need to turn the page. And we're talking piecewise function. All right? We did a little bit of piecewise function last year. All right? But I need to revisit that. That is something that is on the IB test. All right, and so some problems we can't define it easily by just using one equation, one formula. All right, some of them we have to use multiple things to do that, and so those things are piecewise. It's got more than one equation for it. It could have two, it could have three, it could have four, it could have multiple different pieces on it. All right, so I've provided you with this. It asks me to draw the piecewise function. And then I'm going to do a couple other little things with it. Now, I gave you a little bit better graph on yours. So I'm just going to draw that in there. Okay. On this one right here, f of x, or y equals x plus 1. What type of graph is that?
I think that's a 2.
Excuse me, x plus 2, thank you. I was thinking that x is less than or equal to 1. I was ahead of myself. All right. What is f of x equals x plus 2? It's on the very back page. It's slope intercept form. Yeah, it's a line. Okay. Good. So it's a linear problem. So I can go graph that. I'm going to start at 2 because my y-intercept is 2. I'm going to count up 1 over 1. So there's my slope. Now I'm not going to draw the entire line right now. I'm going to look at what I'm given. The second part of this says that I'm going to only draw this line when x is less than or equal to 1. Where would that happen on my graph? To the left or to the right?
To the left.
To the left. So here's where x is equal to 1 right there. And I'm going to draw all that over here to the left. The stuff that I did on the right, I'm not going to draw. Okay. Now, the next part of this, I'm going to draw this graph. What type of graph is that?
It's a negative slope.
It's a negative slope. You might want to flip it and say this is negative x plus 4. That might be a way to rewrite that. That's a little bit easier, I think. My y-intercept is 4. I do have a negative slope, down 1 over 1. So I've got a y-intercept right here, 4. I'm going to count down 1 over 1, so I'm going this way. And I am using the right side since I'm greater than. Okay? Technically, there would be an open circle right there, and I would draw there. Now, what happens to that open circle in this case? It gets closed in, not by the red line, but by my green line. Okay? Okay. What is that the graph of? What other type of function is that?
It's absolute value.
It is absolute value. So we could have done an absolute value function for this as well. Well, we did 2 pieces of it. Now, if I were to ask this question here, f of 0. If I ask that, f of 0. What is f of 0? When x is 0, it would be 2. All right? I can look at my graph and go, okay, there's where x is 0. There's the point that I'm talking about. My answer is 2. Now, could I use my equation? Could use that as well. X is equal to 0. Does that fit on this part of the graph or that part of the graph? Well, it's where 0 is less than or equal to 1. So I would plug the 0 into here, and it's 2 that way as well. Okay? If I were to do this, if I were to ask that, I don't know that I want to graph that. I don't want to extend my graph all the way out there. Again, x is equal to -20. Which piece of the graph would I use? Well, I would use this one again because it's less than 1. So I'd say -20 plus 2, and this would be -18. Okay? So I can use my function there and get to where I need to be. Okay? Everybody all right on the first one? All right. I know I didn't give you a second graph. What I'd like for you to do right now, I'm going to give you a little bit of time. I want you to go graph this one right here. Go graph that second one. You can use the same graph.
In the same graph?
You can use the same graph. You could draw another one if you'd like.
What do I do in calc? Alright, let's put x less than or
Six? What is 6?
All right. So let's talk about it. How do we graph this? 2x plus 1. Where do I start? Positive 1. I'm going to count up 2 over 1, up 2 over 1, up 2 over 1. I'm going to go down 2 over 1 this way. Bless you. All right. Which part of that am I going to graph? The left-hand side, the less than 2. So this is where it's equal to 2. All right. This is where it's less than 2. So I'd have that. What does this mean?
Bless you.
This is f of x equals 6 or y equals 6.
Just like for
What type of line is it?
Horizontal.
It's a horizontal line. It's a horizontal line at 6. So a horizontal line at 6 would do this right there. Now, I don't want that entire line. Only want which part? Where x is greater than 2. So I don't want this part. All right? And then technically, right here at 2, it would be an open circle. Okay? So the blue and the purple put together would be that graph.
That.
Now, the first graph that I gave you, could I have drawn that piecewise function without picking my pencil up? The green and the red. I could, right? That is a continuous graph. Could I draw the second piecewise function without picking my pencil up? No. I draw the blue and I have to pick it up, and then I have to draw the purple, right? And so this is a discontinuous graph. You could have either one depending on the piecewise function. Now, if I ask this, f of 2, what is my answer?
For A or B?
For B. It is 5. Okay?
Is where that,
It's five.
it's a closed circle.
Okay? That's not correct there. That's not where it's equal to. It's here.
It's right there.
Now, if you notice, at the value of 2, they're pointing to two different ideas, correct? One of them is pointing to 5, one of them is pointing to 6, but the one that's equal to is this. If I had asked this question earlier for part A, technically it doesn't matter, which one I put it in, I get the same result. But really, this should be plugged into the first one, not the second. Alright, even though they would give me the same result there.
Should they always go into the first one?
No. Because if I were to ask this, what if I asked f of 10? What's f of 10? Well, 10 is greater than 2, so then it would be 6. Alright, so I've got to look and see what x value, huh?
What if it applies to both?
It can't. Okay, it can only be on one piece or another, it can't be on both. Because if I did this, if I said less than or equal to 2 and greater than or equal to 2, now I'm saying it applies to both, and now it's no longer a function. Because I could get two different answers for one x. Okay? Alright, turn the page, not turn the page, but slide across, and I want you to read this one right here. I'll give you a chance to read that.
The Modi is not a real place. Is it a real place? Yeah, I've heard of Cambodia.
Alright, read the situation.
20% for the first 15 bands. 30% for over 15 bands. Draw a graph of the tax rate. 30 bands. So it's greater than or equal to 30. Could be less than or equal to 30 bands.
Alright, so we have a country, they have a certain tax rate, and so we're gonna write the piecewise function of this first, and then I'm gonna go use the graph to graph this, okay? So what happens at the first here? What's going on? What's the first piece of this situation?
Taxed at 20% for the first 15,000.
Okay, you're taxed at 20%. What does it mean to be, how do I figure that out? To be taxed at 20%? I'm giving you my income, and you're telling me how much tax I owe,
So
all right?
20% would be like the rate.
Yeah, 20% would be the rate, so 0.20x. All right, so 0.20x. I'm gonna multiply my income by the tax rate, which is 20%. Now, when am I gonna use that model?
When it's less than or equal to
When it's less than or equal to 15,000. Anything else here?
The second part of it.
I'm not on the second part yet.
15,
What else about this? I'm gonna put a greater than or equal to 2 part on this as well. 0, right? Can I make negative money? Nah, it doesn't make any sense, right? And so I'm gonna say 0 to 15,000. Yep. Now, what would be the next piece?
30%?
You gonna say that right there?
No, 30,000 up to, so less than or equal to 30,000.
Okay.
So
That-
15,
Just saying you're ahead of me right now. We're looking at this right here. All right. Is that the correct equation?
no, cause you need to include the 15,000.
You gotta include the 15,000 in the front, right? And so if I made $15,000 and one, all right, $15,001, what tax rate would I be charged at?
30%.
So I'm gonna be in 30. So if you make 15,000, I make 15,001, you get charged at 20, I get charged at 30. Is that what this is saying?
I think it's
Yes.
like
Yes.
you get charged with that 20 for the 15,000, and then once you hit,
So that extra dollar I made
yeah.
got charged at
30.
that 30. Okay, not everything got charged at 30.
Yeah.
And
So
so,
it's just a dollar.
so on this,
So it's more.
I'm gonna say that right there. I'm gonna charge 30%, and I'm gonna say X minus 15,000. Because whatever I made, I'm gonna subtract 15,000 because that got charged at the first tax rate. All right. Now, here's what I'm gonna also do. I'm gonna add on here because that's the tax that I've already paid. If I got to the 30% tax bracket, I've already paid $15,000 at 20%.
So what I'm hearing is that.
Plus anything over $15,000, gotta charge that. Now, I think the situation here would be that X is greater than 15,000, alright? I know they have a $30,000 cap there, but they're just saying graph it to 30,000. I don't think there's a $30,000 cap on what you can make. Okay? Now, is this a pretty sophisticated formula? Yeah, it looks a lot more. Could I simplify it, multiply it out, simplify it if I really need to? Okay, all right? I'm not gonna worry about that right now. We can multiply it out and simplify the form, all right? Now, I know I gave you a coordinate plane here, but this is what I'm gonna do. For this one, in this situation, what quadrant really do I need?
This one.
Just the first. So I'm gonna treat it like this. So you can treat your graph the same way there. I'm just gonna treat it as the first quadrant.
What if we have like the bolded black lines?
Yeah, you do already. I would just do this. I just redraw it like that. You could do it that way. I just don't have enough space. All right. Now, because this is pretty good sized numbers because we're talking about thousands and so forth. And so on this, obviously, if I make no money, I'm gonna pay no tax. If I make no money, I'm gonna pay no tax. Now, if I make $5,000, how much tax am I gonna pay? 1,000. All right, that's why I picked that, because it's 20% or 1/5. You with me? So if I make 5,000, then I'm paying 1,000 of that back in tax. All right. Well, I'm gonna count each of these as 1,000. So I'm gonna go 1, 2, 3, 4, 5,000 up 1,000. So right there. I'm gonna do that again. 1, 2, 3, 4, 5, and up 1. And 1, 2, 3, 4, 5, and up 1. Okay? At that point in time, I'm at my $15,000 of income. So this is the first part of that graph. Okay? What now changes?
Now everything added on to that is.
Now everything extra that's being charged at the 30%. So if I make $5,000 and I get charged 30%, how much is that? 1,500. That's correct. Okay? And so on that one, I make 5,000 and then I'm gonna go up 1.5 boxes is what I'm doing. So now my angle changes and it's going up a little quicker. So there's kind of what this piecewise function would look like. Any thoughts on this tax?
Unfair.
Unfair?
It's a lot of money.
It's a lot of money, yeah. How's this compared to America?
I mean, we make, our like salaries are more than that. Like,
You're probably making more money, all right? So we're probably paying more tax. Anybody know our tax rate?
8.25%.
That's our sales tax. That's a state thing, all right? So we pay sales tax anytime we buy something. But our federal income tax, for a good portion of it, it's about 18%. And so up to a pretty good part, you're paying 18% back to government.
Is that like on average or is that?
That's kind of average. Now, ours jumps like this as well, all right? The more, if you hit a certain tier, you get charged a little bit more. Ours isn't 2 tiers, it's multi-tiered. It's like 3 or 4 different tiers, all right, as you're going, okay? Several of the people that make pretty good money get charged about 30%, all right? And so, which could turn into quite a bit of other stuff. You hear people like, well, I'm just gonna give away my money then, so I don't have to, for instance, right here, if I made the $15,000 plus the $1, I might just decide to give away the $1 so that I don't get charged at a higher rate, give it and donate it or whatever. And so when people donate things, it reduces their tax base and they don't have to pay as much.
Some
All right?
of those feeling things are tax write-offs.
Those are tax write-offs. That's kind of how that works. Okay? All right? Cool? All right. So that is, that's piecewise function. Just kind of going back over that. There's one other thing I need to discuss with you today. All right, this is not in your notes. All right, I'm going to give you a couple of things that are important here, but you can, a couple little problems I'm going to give you. You can put at the bottom of the page, you can put somewhere else. All right, so we have a couple proofs that we have to do in an IB. All right, when's the last time you did a proof?
What?
Geometry.
Geometry. You had to do some proofs in geometry. All right, and so the proofs, you did this, but you had to give a reason why. Okay. We're not going to have to give the reason why. We're just going to show the work on how we get to one from one to another. All right. So there's many different types of proofs. All right. We've got deductive, inductive, by contradiction, but we're only going to use algebraic proofs for IB. All right. The goal is to prove that one side is equal to the other side of the equation. All right. Now there's a couple little rules that we have to do. This is the main one right here. The main rule is that you can't solve it like we're doing a normal problem where you would take this and you'd move something over to the other side of the problem. All right? You've got an imaginary fence on the equal sign, and I'm only going to work either the left side or the right side. Okay? So I'm going to take what I think is probably the more complicated side, and I'm going to simplify it until I get it to look like the other side. Okay? That's the goal here. Now, the other thing, at the end, when you're done, when you've got the two sides to match, you have to make a statement. One statement you can make is LHS is congruent. That's this equal sign with the little tilde over the top, all right? That's that congruent sign from geometry. The left-hand side is congruent to the right-hand side. You have to make that statement. It's basically, I'm finished. I got the answer, all right? Or you can make the statement QED, all right? That statement QED is an abbreviation for a Latin term. Let me see if I can find that real quick. All right. The QED is an abbreviation for the Latin phrase quid erat demonstratum, which means what was to be demonstrated or what was shown. All right?
Sounded like you were about to spell, sir.
Yeah, I don't know Latin. All right? And so you do not have to do both of these. You just have to make one of those statements at the end. Many people like the left-hand side is equal to the right-hand side just because that makes sense. Okay? So let's try an example of a couple of these. All right? I'm going to do an easier one, then I'll do a little bit more complicated one. So here is the first one. I have 6/8 is equal to 1/4 plus 1/2. And it asks me to prove that. Okay? So which side looks to be the more complicated side or the unsimplified side? The right. So I'm going to work the right side and I'm going to make it look like the left side. Okay? And so I start here. What would you have to do to add these two fractions? I had to have a common denominator. So the first thing that I would do is I would say I need to multiply this one by 2. I need to multiply this one by 4. So 6/8 would equal to 2/8 plus 4/8. Okay? The next step is I would go on and add those together. So 2/8 plus 4/8 is 6/8. So I now have those two sides equal to each other. So I'm finished, but I do have to make the final statement. The final statement, left-hand side is equal to right-hand side. And I'm done. Got it? That's what you're doing, all right? So really the proof is not the proof that you're used to probably. It's just, can I work the problem? So if I were to give you this problem right there, could you show the work to get me to there?
Yes.
That's essentially what we're doing, all right? Let's try one more of these. Okay?
Like calc, don't get it done.
All right,
What the hell?
here you go.
You always
Hey.
cooking on the last
Whoa.
one.
Whoa.
Yo, you switched up on.
All right,
Real quick.
take a look. Let's write this one down. So I have x minus 2 over x divided by 3x minus 6 over x squared plus x equals x plus 1 over 3. So x minus 2 over 3 divided by 3x minus 6 over x squared plus x equals x plus 1 over 3. Now, we have done this already. All right, this was back in September. This was like our second unit, so it's been a little while since we've done this. Which side are we going to work on this one?
Left.
The left side. It definitely looks the more complicated side. The right side looks easier. Okay. What would be a first move that we could make on that one?
Multiply by 3.
What?
Do we divide fractions?
No.
Normally, what do? We keep,
Change flip.
change, flip. So that's what I'm going to do start.
Ah.
So I'm going to go x minus 2 over 3.
It's over x, not over 3.
Oh, sorry. Thank you. All right. X minus 2 over x. All right. And then x squared plus x over 3x minus 6. And that's equal to x plus 1 over 3. Okay? So I keep, change, flip. I changed it to multiplication. Now, listen. Is this problem right here, x minus 2 over x, is that simple? Can I do anything to it?
And you just cross out the x's.
I cannot cross off the x's.
Because it's like.
Because it's addition and subtraction with division. Can't do that. So this one stays the same. But this one over here, what could I do on top?
Backward.
I can factor. There's an x in both. So if I take out an x, that is x and x plus 1. On the bottom, what can I do with the 3x and the 6?
Take a 3 out.
Take out 3 out. Minus 2. Okay? Now that it looks like this,
You can
what can I do?
cancel.
Cancel the x minus 2.
This x and that x cancel. That x minus 2 and that x minus 2 cancel. Alright? So once I have it written like that, now I'm left with x plus 1 over 3 is equal to x plus 1 over 3. And again, don't leave it like that. Make your qualifying statement at the end. So you could say QED. QED is the shorter way of doing it, but it's the one that a lot of people forget just because it's weird. But left-hand side is equal to right-hand side would also work. It doesn't matter which way you say it.
Why do they forget?
Okay? It's just kind of different. All right? Now, let's take this one and let's finish this here. All right? It says on this one, for what values of x does this mathematical statement not hold true?
-1.
-1. Why -1?
Because it would make the top 0. Because you know how it's like x plus 1? So it couldn't be x1.
Could I have a 0 on top? There?
They have a 0 on top, right?
Can I have a 0 on top? Can't have a 0 on
Bottom.
bottom. Okay? Now, but along with what you said though, if I looked here, if that's a division problem, that was x and x plus 1. So I couldn't have a -1 there because I would have a 0 in the denominator. Okay? So x cannot equal to -1. That's one of the things it can't equal. Say again? What else could it not equal?
Any other negative number?
That's the one I see right here. What can't go there?
Zero.
Positive 2. What the hell?
It's the denominator. I can't have 0 in the denominator of a fraction. So I can't have 0 there. All right? Now, there is a third one.
What?
-3.
Positive 2 is the other.
Oh.
Okay? And now, you may think, well, that's in the numerator, correct? So I can have a 0 in the numerator. But if I were to rewrite this, x minus 2 over x divided by 3x minus 6 over x squared plus x. Is that the same thing as this? Yeah, I just wrote it as a complex fraction instead of writing it as a division problem. All right? So if I had it written like this, if I put a 2 right here, that would cause this to be a 0. Well, it's in the numerator, but it's also the denominator to make the whole denominator 0 for the big fraction, so I couldn't have the 2 there. Okay? If you had a calculator, you could look at that, and that would be broken at those 3 spots. Those are vertical asymptotes at those 3 spots. Okay? All right. So tonight's homework, let me modify it for you just a little bit. Okay? On page 342, it says 1 through 3. Well, question 1 has 5 parts to it. I don't think you need to do 5 parts. Let's just do part C and part D on question 1. But then we're going to do question 2 and question 3. Okay? So on page 342, on question 1, we're just going to do part C and part D. All right? It's got 5 different parts. And then we'll do the other 2 pages, page 56 and page 83. Okay?
Wait, so we're not doing 2 and 3, or we are?
So again, no, we are doing 2 and 3. Question 1 just was 5 questions long, so I just shortened it to 2. So I took out 3 questions for you. All right? All right, we've got about a minute and a half, I think, left.